Hi, good afternoon everyone, and this is Naveena from the Department of Cybersecurity in the Institute of Aeronautical and Engineering, Dundigal. Today, and I have done my previous videos, and I want to share today my video is, the topic is related to the network routing algorithms. In my previous video, and as I have already discussed based on the network layer, and the features of the network layer, the services provided by the network layer, and what do you mean by a routing, and some of the types of the protocols which should be associated with the routing algorithms, and mainly the types of the routing algorithms as I have already discussed in my previous video. And today in this video, and I want to discuss based on that again the types of the routing algorithms, network routing algorithms, and what do you mean by routing, and what do you mean by a router, and what is the process included by means of a routing the packet from one source to the another destination, coming to that, and the routing metrics and the costs. And the next one is the types of the routing, nothing but the classification of the routing, or we can define it the categories of the routing. And after that, the advantages of each routing, like the static routing and adaptive routing and default routing and dynamic routing. So again, and what are the advantages and disadvantages of the dynamic routing, and finally the classification of the routing algorithm by means of the two types, what we can call it as a non-adaptive routing algorithm and adaptive routing algorithm. So today, and I want to define it again. What do you mean by a routing, and the classification of the routing, and what is the purpose of a router when you are dealing about the routing process. So, and I want to define the routing is the process of forwarding the packets from one source to the destination, or from one node to the another node, or from one receiver, from one sender to the another receiver. This is nothing but the process of forwarding or sending the packets from one node to the another node. So, but the best route to send the packet is determined by the routing algorithm. So, a router is a process of selecting path along which the data can be transferred from one source to the destination. And coming to that, the third point, what do you mean by a routing? What are the functions performed by a routing is nothing but it is a special device known it as a router. Routing is also having and consisting of one special device, what we can call it as a router. And what is the purpose of a router means a router works at the network layer in the OSI reference model, and the internet layer, what we can call it as a TCP IP model, in the OSI model as well as in the TCP IP model. TCP IP model, we can able to see how the mode of the working of a router from one layer to the another layer. And the last definition is nothing but what do you mean by a router and purpose of a router, as I have already seen. A router is a networking device which can forward the packet based on the information available in the packet header and forwarding that packet to the concerned destination by means of the table which will be available according to the router. So in this, and I have already told and discussed based on that routing, and what do you mean by a router, and how the router will be working, and what a router will be consisting, and how it will able to work by means of a network protocol layer, and how the device it will be working while sending the packet from one sender to the another receiver. And next one, what do you mean by the routing protocols? The routing protocols use the metric to determine the best path for the packet delivery. And next point is the metrics is the standard of measurements. What do you mean by metrics? Metrics is defined as it is nothing but the standard of measurements such as hop count, bandwidth, delay, current load on the path of the packet which will be going from one sender to the another destination, used by a concerned routing algorithm to determine the optimal path to reach one packet from one source to the another destination. So next one, the routing algorithm initializes and maintains the routing table for the process of the path determination. Why? Because the path already fixed or determined before the sending one packet from one node to the another node. And next concept is nothing but routing metrics and costs. Already routing we have to see, and routers will also be defined, and routing protocols already determined, and routing metrics and the cost. What do you mean by routing metrics and the cost? The measurement of a routing protocols or routers is nothing but the routing metrics and the cost. So routing metrics and costs are used for determining the best route to the destination. When the packet is ready to travel or to forward it from one node to the another node, before it will have any to reach the destination, or it will have any to travel on a particular physical path or a logical connection which will be established. So in that path, the routing metrics are available, so to determine the best route for each packet to transfer from one sender to the another receiver, or from one node to the another node. And the second point is nothing but under the routing matrix and the cost, the factors used by the protocols to determine the shortest path. These factors are known as a metric. So metrics are, if you can define in another way, metrics are the network variables used to determine the best route to the destination. Metrics are meant for to determine the network variable. Suppose it is nothing but one of the path a packet can able to transmit from one sender to the another receiver. A matrix are the network variables used to determine the best route. So here a packet can able to, suppose if you can assume a packet can able to, three path of corrections will be there. A packet can able to transmit either by means of a route 1 or route 2 or route 3. So before that transmitting or transfer or sending the packet from one source to the another destination, a packet can need to obtain or need to verify which path is best route and which is the shortest path to reach its destination. So that is the prior identified by a one packet by means of a router which path is better one, which path is the shortest path to forward from one node to the another node or from one sender to the another receiver. So this is the main use of metrics which are obtaining under the network layer. For some protocols use the static metrics that their value cannot be changed. For some other routing protocols which are used the dynamic metrics means that their value can be assigned by means of a system administrator. Again, I need to define it again. What do you mean by a matrix means? Routing metrics and cost are used for determining the best route when the packet can able to travel or forwarded from one node to the another node or from one source to the destination. Which path should be the best and which path is the shortest path to reach its goal or destination as early as possible. And these are the main applications or uses of the routing metrics and cost. And coming to that, the second points are the second concept of the routing metrics and the costs are nothing but the hope point. What is the first metric means? Under that, this is the routing metric one is the hope count. Hope count is defined as a metric which specifies the number of passes through interneting devices such as router, either by means of a packet must travel in a particular route to move from its particular source to the destination. That is nothing but the hope count, and it is the first routing metric. Second one, if the routing protocol considers the hope as a primary metric value, then the path with the least hope count will be considered as the best path to move its packet from one node to the another node or from one source to the another destination. So how the path will be considered means by means of a routing protocol only needs to consider, that means which path will be the best to reach that packet as early as possible from one node to the another receiver. And the second metric is nothing but this is the routing metric 1, this is the routing metric 2. The second routing metric is nothing but it is the time taken by the router to process, queue and transmit a datagram to an interface. So the protocols use this metric to determine the delay values for all the links along the path by means of end-to-end. The path having the lowest delay and it will be considered as the best path to reach the packet from one source to the another destination. Coming to that, the next routing metric concept or the third element of the routing metric is nothing but the bandwidth, which is nothing but the routing metric 3, what we can call it as a bandwidth. The capacity, as I have already explained in my previous videos, what do you mean by bandwidth? That is nothing but the capacity of the transformation of or sending the packets bits per second, or the transmission of a data packets under the mode of bits per second to reach their destination or a receiver is nothing but the bandwidth. If you can define the bandwidth in a secondary way, means the capacity of the link is known as a bandwidth of the link. The bandwidth is measured in terms of bits per second. As I have already told to you, it is, if you can consider the bandwidth, it is nothing but the bits per second. The next point is nothing but that link that has a higher transfer rate like gigabit is preferred, or that link that has the lower capacity of 56 KB. That means the gigabit is preferring which can able to hold the capacity of more or less 56 kilobytes per hour. And the third point is the protocol will determine the bandwidth capacity for all the links. That means the links are nothing but the path and the overall higher bandwidth will be considered as the best route. So these are the main routing metrics and the costs which should be included under the network routing algorithms. So coming to that, if you can discuss about the types of routing or the classification of the routing. Routing can be classified into 3 categories. The first one is the static routing, second one is the default routing, third one is the dynamic routing. And if you can make it or wantedly, if you can see the pictorial representation of a network algorithms under the part of the types of routing, the first one is the static routing, second one is the dynamic routing, third one is the default routing. And coming to the first one, according to the pictorial representation, this is nothing but the static routing. Static routing is also known as non-adaptive routing, and it is a technique in which the administrator manually adds the routes in a routing table. And second point, a router can send the packets for its destination along the route which will be defined by means of a routing administration. So in this technique, the routing decisions are not made, and it will be based on the condition of a topology of the networks which will be available by means of a network administration. Next one. And coming to the next one, advantages of the static routing. So what are the advantages of a static routing means? These are the following some of the advantages which should be privileged by means of a static routing. The first one is the no overhead. Second one is the bandwidth. And no overhead means it has no overhead on the CPU usage of the router. It is based on the advantages of the static routing is based on the CPU usage of the router. Therefore, the cheaper router can be used to obtain the static routing if it is not having no overhead on the CPU usage of the router. This is the first advantages of the static routing. Second one is the bandwidth. As I already explained, that bandwidth is nothing but it has not bandwidth usage between the routers, and security means it provides the security as a by means of a system administrator which will allow only to have control over the routing protocols to a particular network. These are the two types of advantages of the static routing. The first one is the no overhead, second one is the bandwidth. So coming to that, the disadvantages of the static routing, as I have already seen, we have seen that what do you mean by static routing and what are the advantages of a static routing. So coming to the disadvantages of the static routing, following are the disadvantages of the static routing, and for a large network, it becomes a very difficult task to add each route manually to the directed by means of a one packet transmitted from one node to the another node to a concerned routing table. And here, the second point is nothing but if you can discuss or if you can think in a secondary way, the system administrator should have a good knowledge of topology as he has to add each route manually according to the routing table which will be provided by the router administrator. So coming to that, the next one is nothing but the default routing. And coming to the default routing, it is one of the technique in which a router is configured or defined to send all the packets to the same host device, and it doesn't matter whether it belongs to a particular network or not, but it can able to configure to send all the packets to the same host device, and it does not matter whether it belongs to a particular network or not. And second point is nothing but a packet is transmitted to the device for which it shall be configured in the default routing mentioned in a particular way. Third point is nothing but the default routing is used when network deal with a single exit point, not a multiple point. It will be limited with a single exit point. It is also useful when the bulk of transmission networks have the transmission of the data to the same host of the same device. So, and coming to that, the last point is nothing but when a specific route is mentioned in the routing table, the router will choose the specific router rather than the default router. The default router is chosen only when a specific route is not mentioned in the routing table. These are the main points which should be included under the default routing when we have discussed again. It is one of the technique, and here and the same a packet or the bulk of packets can able to send to the same host device to a particular network or some concerned network, and here a packet is transmitted to the device for which it will be configured to a default routing and consisting of single exit point level, and when a specific route is mentioned in the routing table, the router will choose the specific route rather than the default route. The default route is choose only when a specific route is not mentioned in the routing table. So coming to that, the second routing of a types of the classification of the routing algorithms is nothing but the dynamic routing. It is also known as adaptive routing, and the second point is known as it is a technique in which a router adds a new route in the routing table for each packet in response to the changes in the condition or topology of the network. So here if you can take the diagrammatical representation of a routing table also consisting of, so if you can take the 3 columns and rows, and it will be consisting of the routing, the data packet name and the data packet number and the routing packet address. It seems address, name and the number. This is one of the routing table. If you can take it, if you can assume it, this is nothing but the one of the routing table in which whatever the packet it will be transmitted or sending or forwarded by means of a one data link or a path or a logical connection which should be established. Each data packet should have a need to hold one address and the number of the data packet. Suppose it will be data 1 and the address of the data packet which data link or a logical connection or a path it needs to go to reach its destination. That is nothing but the other side of the address, and the sender address also be there. So a routing table, finally I want to discuss a routing table consisting of a data packet name and its number and its address. So here the dynamic protocols are used to discover the new routes to reach the destination. That means to already a data packet can able to transmit it from one node to the another node. So here a dynamic protocol are used to discover the new routes to reach the destination. Like suppose if one data packet is determined or assumed or determined to send, the packets are able to transmit from one section to the another section, from one node to the another node. Dynamic protocols are used to discover the new routes to reach the destination. Means if there is any congestion control in between them, or if there is any heavy traffic control, or if there is any occur error occur will be there. So then immediately the data packet will be discarded and it reaches to the initially whatever the sender it will be coming, it will discarded and it transmitted to the sender. The sender can check it by means of a checksum detecting techniques or cyclic codes. Then only it will restarts or retransmit the same packet in the same way. So here any congestion or any error flow or any error will be occurring. So for that only it will discover the new routes. So the data packet can able to choose the another path to reach its concerned destination. So for that purpose the dynamic protocols are used to discover the new routes to reach the destination. Again, the second point is nothing but in dynamic routing, the RIP and OSPF are the two main protocols which are used to discover the new routes, which are used to helpful in the dynamic routing. These are the two types of protocols which are obtained to discover the new type of routes. So if any route goes down, then the automatic adjustment will be made to reach that destination. That's as I already explained. If while sending or passing the packets from one node to the another node, if any disturbance or any adjustment, if any data packet will be discarded, so automatically it can able to adjustment will be made to reach that packet to the destination in a some other route. So the other side of the second way of routes will be determined or discovered by means of a dynamic routing algorithm. So coming to that, the dynamic protocol should have the following features. So what are the features means? The first one is all the routers must have the same dynamic routing protocol in order to exchange the routes. That is the first point. And second one is if the router discovers any change in the condition or the network topology. So what a topology consists, it consisting of one subnet which will be connected by means of a number of hosts like host 1, host 2 and host 3 and host 4 and host 5. So if the router discovers any change in the condition or topology, then the router broadcasts this information to all the remaining other routers. That means if there is any discovers if this condition, the main central condition or the hub of the condition, the subnet of a condition, it will be disturbed or any error it will be occurred, it will need to inform to all other hosts which should be linked by means of a one data subnet. So coming to the advantages of the dynamic routing, it is easier to configure and determine and it is more effective in the selecting the best route in response to the changes in the condition or the topology. Not only the subnet and what are the hosts, it should be linked with the subnets to provide the best route to reach its destination. The dynamic protocol will act as a good role or vital role to send the packets from a one node to the another node in a successive way. So coming to that, some of the disadvantages of the dynamic routing as well as and most of the dynamic routing having the advantages of the its features, but the disadvantages of the dynamic routing, some of the will be there. So that will be, it is more expensive in terms of CPU and the bandwidth usage. Why? Because it is more expensive in terms of CPU and the bandwidth usage. In terms of CPU means and the processing is also very difficulty, and the bandwidth means the bits per second of data packets were unable to transmit from one node to the another node. So it is very expensive if you can calculate the terms of CPU and the transmission of the data packets by means of a BPS or bandwidth per second usage is very much expensive while you are discussing with dynamic routing, and this is one of the disadvantages of the dynamic routing. So coming to the next one, it is less secure as compared to default and the static routing. Why? Because coming to that, the default and the static routing, it will be considered as a less secure. Why? Because it doesn't hold the number of bits of the data packets by means of a BPS, and the terms of processing the data packets or data frames from one node to the another node. Hence, the term we can call it as a less secure as compared to default and the static routing. Coming to the routing algorithms, in order to transmit the packets or transfers or sends the packets from one source to the destination, the network layer must determine the best route through which the packets can be transmitted. That means before a packet can able to transmitted from one source to the another destination, the network layer, what is the main applications of the network layer means it will determine the best path from one node to the another node before a packet can able to travel or sends from one node to the another node. This is the first and foremost and primary application of a network layer. So the network layer is always meant for to determine the best path or the best route on which the packets can determine that path to reach their destination from one source to the another destination, from one sender to the another receiver. Coming to that, the third disadvantages of a dynamic routing, whether the network layer provides the datagram service or virtual circuit service or datagram service, the main job of the network layer is to provide the best route. The routing protocol provides this job. How the network layer, that means the routing will be done means the routing of a packets or the determination of a one path to a one packet from where it can services starts or where it can reaches, it will be determined by means of a routing protocol, and the path will also be established or determined by means of a particular routing protocol which should be associated at that particular layer. So coming to the last point of a disadvantages of the dynamic routing, the routing protocol is a routing algorithm which can provide the best path from the source to the destination. The best path is the path which can select is the least cost path or the shortest path from one source to the another destination, which means the routing protocol is a routing algorithm which provides the best path from one source to the another destination. This best path is the path that can minimizes or determines the least cost path or the shortest path to a one packet. When the packet it will able to come or transmits from one sender to the another receiver. So the routing protocol or a routing algorithm which can provides or it will gives the option to select the best path whenever a data packet can able to transmit or ready to transfers from one sender to the another. Before that only they need to decide which path is best and need to determine before the travel which is the least cost path and which is the shortest path to reaches its destination as well as possible. So these are the main disadvantages of the dynamic routing. Coming to the classification of a routing algorithm. The routing algorithm is divided into again the two type of categories. The first one is the adaptive routing algorithm. Second one is the non-adaptive routing algorithm. Coming to that, the first one of a routing algorithms classification, adaptive routing algorithm. An adaptive routing algorithm, if you can define in a single way, it is nothing but it is a dynamic routing algorithm. An adaptive routing algorithm is also known as dynamic routing algorithm. This algorithm, what is the advantages of using this adaptive routing algorithm means this algorithm makes the routing decisions. Mainly the usage of an adaptive routing algorithm is it will make the routing decision based on the topology and the network traffic which will be available on a one network layer. And second element or the second parameters of a routing algorithm under the adaptive routing algorithm is the main parameters which should be included under the adaptive routing algorithm is nothing but related to the algorithm are, so the main parameters or the metrics of a one adaptive routing algorithm are nothing but these are the hop count, distance and the estimated time or the bandwidth, if you can take the parameter of a bandwidth. These are the metrics we should be available, or if you can discuss by means of a adaptive routing algorithm. So in this up to now we have to see the adaptive routing algorithm, and next one is non-adaptive routing algorithm. So here again an adaptive routing algorithm, again it will be classified into three types. That means first of all this is nothing but the routing algorithm, and second one again it will be divided into that adaptive routing algorithm and non-adaptive routing algorithm. In this again an adaptive routing algorithm can be classified into three types. What do you mean by centralized algorithm, linked state algorithm and distributed algorithm? Centralized algorithm and centralized and distributed and linked state. So again the adaptive routing algorithm can be divided into three types: centralized, distributed and the linked state algorithm. Again under the non-adaptive also it will be classified into two types. What are those two types? Flooding and the random walks. The non-adaptive also can be distinguished or classified into two types, that is that flooding and the random walk. Flooding and the random walks. So these are the total classification of the routing algorithms. Again I need to explain the routing algorithms or the classification of routing algorithms here. The first one is the adaptive routing algorithm, second one is the non-adaptive routing algorithm. Again adaptive routing algorithm, it will be centralized, located and classified or and distributed into centralized, distributed as well as the linked state algorithm. Coming to that non-adaptive routing algorithm, flooding algorithm as well as random walks. So and up to now we have to already seen and what are the metrics and what do you mean by adaptive routing algorithm. So coming to that, the categories of a adaptive routing algorithm, what we can call it as a, let us see one by one. An adaptive routing algorithm can be classified into three types. The first one is the centralized algorithm. It is also known as global routing algorithm, where and when it computes the least cost path between the source and destination by using complete and global knowledge about the total network. This algorithm takes the connectivity between the nodes and the link cost as input, and information is obtained before actually performing any calculation of sending the number of data packets which can able to transmit from one source to the another destination. Mainly we have to see or identified under the centralized algorithm is nothing but it is the globalized algorithm which can able to compute the least cost path between the source and destination of a one node. That means one particular path, it can able to determine to one data packet what a mean by a least cost path or a shortest path. That means it can able to transmit or forwards from one or travels from one node to the another node. And this algorithms already takes the connectivity between the nodes. That means connectivity between the nodes means there should be a link between the node 1 and the node 2. This is nothing but the connectivity. A node 1 is connected at that particular point, that the starting of the point, whereas the node 2 will be connected at the end of the one destination route. That means at the end of the route, what we can call it as a node 2 or a receiver, and at the starting of the route, what we can call it as a source route. And this is the information we can obtain before actually performing any calculation. So coming to the second one of a adaptive routing algorithm, it is nothing but the linked state algorithm, which is refined as a or referred as a centralized algorithm, since it is aware of the cost of each link in the network layer. It can define or it is eligible or applicable to define the aware of the cost of each link which will be obtained in the one network. Suppose it is one of the network, the each links which will be defined or associated with that network, it will be giving the awareness or determined by means of a link state algorithm. Hence the name links, link 1 and link 2, link 3, link 4, link 5. So these are all the multiple links which will be associated in the center of a one network layer. So the route or the path of each links will be determined by means of a link state algorithm in the total network. And coming to the next one is the isolation algorithm, and it is also one of the algorithm which obtains the routing information, which is used to obtain the routing information by using the local information rather than getting information from other nodes. It will only helps to obtain the routing information while transmits the packet from one node to the another node. That means whether this route consisting of any heavy traffic and doesn't hold any traffic to reach that one packet to the destination, or if it will be fully traffic or heavy flow, it will be there. So shall this packet can able to take it or lead it in a second way, or if this route will also be having heavy load, and is that packet can able to transmit or follow in a this type of third route. So these are nothing but the information regarding the routing and the transmission of a routing of the packets from one node to the another node will be determined by means of isolation algorithm by giving the local information rather than gathering information from other nodes. So the fourth point of a adaptive algorithm is nothing but a distributed algorithm. The name, it seems, distributed means segregated. It is also known as, it is not a centralized. The centralized one is a link state algorithm, as I have already explained, and distributed algorithm is a non-centralized or decentralized algorithm, as it computes meant for the least cost path, for the determination of least cost path between the transmission of the data packets from one source to the another destination in the mode of a iterative and distributed manner. Hence the name, it comes in the mode of a distributed algorithm, means it will determine the least cost path of a number of packets which they can able to send or transmitted from one source to the another destination when it meant for happening or undergoes the number of iterations and in the mode of a distributed manner. In the decentralized algorithm, no node has the knowledge about the cost of all the network links. That means a single node, the starting node if you can take, it doesn't have any knowledge about the cost of all network links. That means and how many packets it will be travel or send from one source, one node to the another node, or how this network can able to link through many links, multiple links, or whether they can able to transmit any number of packets from one node to the another node. These are all the points they don't have idea. They did not hold any such type of knowledge about the costing of all the network links under this distributed algorithm. So again, I need to make the review of an adaptive routing algorithm can be classified into three types. The first one is the centralized algorithm, and which it is also known as global routing algorithm, consisting of used for the determination of least cost path of sending the packets from one node to the another node or from one source to the another destination, and it will be holding some metrics like like a cost of inputs and the information regarding the routing of the packets by means of a routing protocol, and the calculation of the percentages of the data packets which can able to transmit from one source to the destination by means of a bits per second. Second one is the link state algorithm, which we can call it as a centralized algorithm, and since it is aware of cost of each link which should be associated under the one subnet or the one network layer, it will be associated. And next one is the isolation algorithm, which means completely it will gives or reflects on the routing information on which data packets can send or travels from one source to the another destination, or the data packets on which route the data packet can able to determine to transmit or to travel from one node to the another node. And last one is the distributed algorithm, and we can define it, or if you can make the definition in a secondary way, it is nothing but the decentralized algorithm, as it computes the least cost path between the source and the destination in a iterative and distributed manner. So again, and coming to that, the second part of a routing algorithms are, the first one is the adaptive routing algorithm, and second one is the non-adaptive routing algorithm. Under this non-adaptive routing algorithm, it is also known as static routing algorithm. The non-adaptive routing algorithm, if you can define in secondary way, it is nothing but the static routing algorithm. And when booting of the networks, it will be happening, the routing information stores to the routers. A non-adaptive routing algorithm do not take the particular decision based on the network topology or the subnet which will be available on the computer networks of a one network traffic. So this is nothing but the non-adaptive routing algorithm. Again, the non-adaptive routing algorithm is of two types. Again, I have already classified while I have a mean to explain before the starting of the explanation of the classification of a routing algorithm. The non-adaptive routing algorithm also again classified into two types. The first one is the flooding, second one is the random talks. The non-adaptive routing algorithm is of two types. The first one is the flooding. Flooding means, in case of flooding, every incoming packet is sent to all the outgoing links except the one from it has been reached. So the disadvantages of the flooding is that node may contain several copies of that particular packets. What do you mean by a flooding? Here, if you can take the example of a flooding, that means it is the node 1, the node 2, which a data can able to transmit on a particular determined path or a logical connection or a source path which a packet should be determined to transmit from one node to the another node without getting any acknowledgement from the node 2 to the node 1. If you can able to send the many number of data packets like in this mode only, so whether the node 1 or the sender did not have any information, all these type of data packets can able to reach it to the node 2 or not, and how far it will be reaching, whether all they have selected in a correct path, whether all the data packets can able to transmit in that same mode of path only, or whether the number of data packets which should be assigned on a one particular path, whether they can able to transmit on the determined path it or not only. So the node 1 did not have any such type of acknowledgement. Whenever a node 1 or a sender or a source does not consisting of or does not getting any type of acknowledgement from the node 2, then only that process what we can call it as a flooding. Flooding means simply the floating or the heavy flow of packets without getting a concerned acknowledgement to the router or a sender to the node 1. It is nothing but the flooding algorithm, or the non-adaptive routing algorithm of the first one is nothing but the flooding algorithm. That concept what we can call it as a flooding, without getting any acknowledgement from the node 2 to the node 1 related to the type of the packets, the number of the packets which can able to transmit from one node to the another node. It is nothing but the flooding. In case of flooding, what will happen? What is the conditions? If you have identified or check here by means of a flooding means, every incoming packet will have a need to hold some particular acknowledgement here. Suppose if this packet will be coming, this is some data packet 1, this is some data packet 2, this is from data packet 3, this is some data packet 4, this is some data packet 5. So if all the data packets are able to travel or forwarding or sending from one node to the another node, so every packet will lead to the destination by means of a consent acknowledgement, which that acknowledgement needs to send by a node 2 to the node 1. So if all the incoming packets is sent to that outgoing links except the one from it has been reached. So what we have seen, the second disadvantages of a non-adaptive routing algorithm means under the sense of flooding. So the data packets not only able to transmit already the determined path of its particular route, it can able to take the other routes which will be determined to travel the other packets to reach their destination. If the flooding will be occurs without intimation, they will take the second source of path or second source of logical connection to reach their destination by means of able to transmit to that second level. So that is nothing but the flooding. So the disadvantages of the flooding is that node may contain several copies of the particular part. So this packet consisting of the data number 4 packet and address some having the IP6. So if it can well travels and the destination will have a need to consisting of, and so the data for packet is arriving. Again, if it does not go up to the last level, in the middle it will be discarded due to the heavy flooding. It will take the secondary path means again here also the data packet 4 and this address is also along with this address, it will be holding the same address. And again, if there should be any occurrence of any flooding, it will be identified. It will take the automatically the third source of path, what we can call it as a route 3, to reach their destination by holding the same data packet number and its IP address. This is nothing but the disadvantages of the flooding algorithm. So coming to the random walks, in case of the random walks, it is nothing but the second algorithm of non-adaptive routing algorithm. In the case of random walks, a packet sent by the nodes to one of its neighbors randomly. And advantages of using random walks is that it uses the alternate routes very efficiently. It can uses the alternative routes very efficiently. That means the main concept or the main point what we have to recognize or identified by means of a random walks are nothing but a packet sent by the node to one of its neighbors randomly. That means a packet is transmitted from one node to the another node, from one node to the another node. So whenever it will reaches, the second path will also be there and the third part will also be there, the first part will also be there. Whenever a packet is ready to transmit from one node to the another node, automatically it reaches the destination. So this from this layer, from this path, it will automatically comes to that second path. Whenever it reaches the second source path of a destination node, automatically it will get down to the third source path of a one network layer. So again, whenever it will reaches the destination, automatically it will get down to the fourth source path to travel that packet from one source to the another destination to reach its successive destination path. This is nothing but the random walks means whenever the packet reaches the destination, automatically it will sends to the another node or to the another layer automatically, or it's sending the same packet to the neighboring layers by means of in a random way. Hence the name it called it as a random walk means a packet can able to send by the node to one of its neighbors randomly. So here a load can be calculated in a variety of ways, such as, what do you mean by a load? Load means the number of data packets or the transmission of the data packets on a one single path. It is nothing but the load. What we can call it as this term load. A load can be calculated means the passing of a data packets or the number of a data packets can be calculated in a variety of ways, such as CPU utilization and packet processed per second, what we can call it as a bandwidth. And second one is if the traffic increases, what we can call this condition, that heavy flow, then the load value will also be increased. What are the three type of measures which we can calculate it to transmit the data packet from one node to the another node means, first of all, the utilization of the CPU. Second one is the packets processed per second. That means that what we can call the parameter or the metric bandwidth. And the third one is the traffic increases means what we can call that condition heavy flow. Then the load value will also be increased. The load value changes with respect to the change in the traffic. So coming to that, the second one is the reliability. Reliability is one of the major metric or factor and may be composed of a fixed value. That means it depends on the network links and its value is measured by means of a dynamically. Some networks may be go down more than the other networks. It will be linked before the data packets can able to transmit it, or it will be getting down when it reaches the destination from one layer to the another layer. So if you have identified any network failure, that means the sending and receiving of the packets on a one path can able to failure means some network links repaired more easily than the other network links may be obtained to set the path. Before, after the setting the path, if there would be any disruption or causing any disturbance while transmitting one data packet from one source to the another destination. So before that, some network links might be established to repair more easily than already if the existing path will be corrupted or disrupted in any other format. So coming to that, the second point of a reliability factor can be considered for the assignment of based on the reliable ratings and based on the generally numeric values assigned by the system administrator. The reliable factor is based on the two type of metrics, nothing but the reliability rating as well as numerical values assigned by the system administrator. These are the number of the metrics or the factors which will be influenced by means of sending the data packets from one layer to the another network layer. So again, and I need to make the review of what is the type of the contents which should be included by means of the routing type of algorithms and the classification of a routing type of algorithms and routing metrics and the cost. So again, in this topic, and I have already discussed what is the routing, and at the end of this video, and I want to explain, I want to elaborate, and by this video the students can able to learn and identify and analyze the things of what is meant by routing and how the routing process will be done and what are the type of protocols and what is the main application of routing protocols with effect to the routing algorithms while selecting the path or determination of the path of a one data packet transmission from one node to the another node, and how the packet transmission will be happening by means of a different paths which will be determined by means of a routing protocols, and how the router will be worked by means of two types of important layers, what we can call it as the OSI reference model as well as the TCP IP model, and what do you mean by a routers, and after that what are the metrics, routing metrics and the costs which should be available while transmitting the data packet from one node to the another node, and what are the main types of routing measures or metrics means the hop count as well as the delay and the bandwidth and the link, the network links or the subnet of a link. It will holds the higher transmit of gigabyte per second, what we can call it as a 56 kbp. And after that, and again I have already explained to you the types of the routing and the classification of the routing mainly under this one, and the static routing and dynamic routing as well as the default routing. Under that static routing, advantages of the static routing and again the disadvantages of the static routing, as well as under the default routing, again some of the advantages and disadvantages of the default routing. Coming to the dynamic routing, what do you mean by a dynamic routing, and what are the main two protocols, what we can call it as the RIP and OSPF protocols, and what are the main tasks which should be played by means of a RIP and the OSPF protocols under the dynamic routing, and what do you mean by a dynamic routing association with the adaptive routing. What are the roles and what are the responsibilities followed or held by a dynamic routing, and what do you mean by a the following features which should be available by means of a dynamic protocol routing, and that means the advantages of a dynamic routing in the form of a selection of a best route path to sending the packets from one node to the another node, and based on the network topology also, connecting with the network topology also, how the network layer it should be defined, and what are the conditions applicable not only by means of a subnet, and what are the links available throughout the subnets. And coming to that, the disadvantages of a dynamic routing based on the two main concepts, nothing but the CPU and the bandwidth usage, and how far it will be less secured when comparatively with the default and the static routing. And coming to that, last one is the classification of the routing algorithm. Again, it will be based on the classification, divided into, categorized into two types. The first one is the non-adaptive routing algorithm. Second one is the adaptive routing algorithm. And what are the factors and metrics and the measures which should be associated with the adaptive routing algorithm, as well as, and what do you mean by the classification of the what do you mean by adaptive routing algorithm? And coming to that, the classification of a adaptive routing algorithm can be categorized into four types. What do you mean by centralized algorithm? What we can call it as a global routing algorithm. And coming to that, it will also be based on many of the metrics and measures like the link cost as an input, and the information which will be obtained before a packet can able to select the path to transmit from one node to the another node. After that, the link state algorithm, which will be referred as a centralized algorithm, and which is isolation algorithm. It is especially meant for the information regarding the routing of the packets or the path on which the data packet can able to transmit from one route to the another route or from one node to the another node. That means it is especially meant for routing the information by using the local information. Coming to the distributed algorithm, it is nothing but the decentralized, as well as in the form of a number of iterations in the mode of a distributed manners, which is used to determine the least cost path or the shortest path, which should be determined whenever a data packet wants to travel from one node to the another node. After that, coming to that, the non-adaptive routing algorithm. In this, again, it will be divided into the mainly the two types. Non-adaptive routing is meant for, it is also known as static routing algorithms, and again, it will be divided into the two types. The first one is the flooding, second one is the random walks. Based on the flooding means it is the excessive flow of data packets on a one determined path without getting the acknowledgement from the node 2 to the node 1, or without getting the acknowledgement of a destination part to the source route. That means how many packets it will be received by a one destination source or a one destination node. Second one is the random walk, means whenever a packet sent by a node 1, automatically when it reaches to the destination, it will be shared by means of a routing algorithm or protocol to the another layer, or what we can call it as to the neighboring layers. What we can call that condition is known as a neighboring, sharing the packet sent by a particular node to one of its neighbors randomly. Hence the name, what we can recollect it as a random walks. And coming to that, the load and the measures and the metrics of a load. Load means the heavy flow of flowing the data packets or datagrams on a one determined path from one node to the another node shall be considering the main factors are nothing but the CPU utilization and the bandwidth and the heavy flow. So again, mainly all these factors are included by means of a reliability. The reliability is the major and important metric factor which you can measure dynamically when you are working with the network topology on a network layer. This ends the video. Thank you all for watching this video, and keep watching for my next video. Thank you one and all.
Like, share and subscribe. Hit the bell icon for more updates.